Hello students, I'm using this Show Me app and I'm trying it out for the first time. Okay, in this video I'm going to explain how to find the derivatives of certain functions using product rule. Now I'm using my hand, in fact I'm planning to buy a new stylus, so in case if it is not very clear, please pardon me. Okay, first let us take a function f of x equals x plus 1 multiplied by x square plus 1. Okay, let's say I want to find the derivative of this function. Now I can use the product rule to find the derivative, or I can simply open the bracket. Okay, fine. So now I can simply open the bracket. Let me do that. X cube plus x squared plus x plus 1. Now as you can see, this function can be written as sum of 4 simple functions. Now it is very easy to find the derivative. Let me find it. So f dash of x equals derivative of x cube is 3x square plus derivative of x square is 2x plus derivative of x is 1 plus derivative of 1 is 0. That's all. So the answer is 3x square plus 2x plus 1. Okay. Now let me find, is there another way to find the derivative? That means, can we find the derivative of the given function without expanding the brackets? Let me see. Let me just erase this answer. Okay. I hope you remember that we got the derivative as 3x square plus 2x plus 1. Okay, let me do it now. Now I'm going to use product rule right now. Okay, f dash of x equals, okay, as you can see there are two functions in product. The first function is x plus 1 and the second function is x square plus 1. So what I'm going to do is I'm going to find the derivative of the first function, which is 1 plus 0 multiplied by, I'm going to keep the second function as it is, that is x square plus 1. Okay, plus, now the second term is, I'll keep the first term as it is, which is x plus 1, and I'll find the derivative of the second term, which is 2x plus 0. Sorry, it looks like a 6. Okay, it's 0. Now when you open the bracket, you get x square plus 1 plus 2x square plus 2x. So the final answer is 3x square plus 2x plus 1. So as you can see, we got the same answer if you use the product rule. Okay, now you might wonder, what is this product rule? How do we use the product rule? Okay, so what I'm going to do is, I'm not going to show you how we derive the product rule, but I'm just going to tell you the technicalities. Okay, let me say a function f of x, say a function f of x is in the form of, let's say, h of x into g of x. Okay, now where h of x and g of x are also functions of x. Now the product rule says that f dash of x, that is the derivative of f of x, is nothing but h dash of x multiplied with g of x plus h of x multiplied with g dash of x. Now here h dash of x is nothing but the derivative of h of x, and g dash of x is nothing but the derivative of g of x. Okay, now you might wonder, why do we need this? Why do we need this product rule? Now the previous sum, we could very well find the answer. We could very well find the derivative without using the product rule. So what is the use? What is the need of this product rule? Okay, let me show you. Let me give you another problem. Let's say f of x equals x squared into sin x. Now as you can see, this particular problem, if you have to find the derivative, you need to use the product rule. There is no other way to find it. Of course, there is a we can find the derivative using first principles, but I'm not going to that. So let me use the product rule for this. The first function is x squared and the second function is sin x. Okay. So as per the product rule, f dash of x equals, so the first term has, first I will find the derivative of x squared, which is 2x. So 2x multiplied with sin x. So I will not do anything with the second function, I'll keep it as it is, plus the first term is over. The second term, I'll keep x squared as it is, I'll multiply it with the derivative of the second function. The second function is sin x, so the derivative is cos x. Okay, so the final answer is nothing but 2x sin x plus x squared cos x. I'm sorry, it doesn't look neat. Okay, fine. So 2x sin x plus x squared cos x is the derivative of x squared sin x. Okay, let us see another problem. Let us see another function f of x equals, let's say, x cube plus x squared plus 1 multiplied with ln x. Okay, you know that ln x is nothing but log x to the base e. Okay, here the first function is a cubic function, an algebraic function, x cube plus x squared plus 1, and the second function is a logarithmic function. Okay, let me use the product rule. So f dash of x equals, so I will differentiate the first function. So the derivative is derivative of x cube is 3x squared plus derivative of x squared is 2x, derivative of 1 is 0, multiplied with ln of x. So first term is over, plus the second term, I'll keep the first function as it is, that is x cube plus x squared plus 1 multiplied with, now I'll differentiate the second function. We all know that the derivative of ln x is 1 by x, 1 over x. Okay, fine. Now next you can simplify this expression. I think this is what you'll get as a final answer. You'll get x squared plus x plus 1 by x plus, now 3x squared ln x, 3x squared ln x plus 2x ln x. Okay, so this is the final answer. Okay, so let us see one more problem. Let us see a problem with three functions now. Let us say the function f of x is in the form h of x multiplied by g of x multiplied by, let's say, r of x. Okay, so to find the derivative of this function is very simple. So f dash of x is, I will differentiate the first function, that is h dash of x multiplied with g of x and r of x, plus second term will be h of x multiplied with g dash of x multiplied with r of x, and the final term is h of x multiplied with g of x, which is multiplied with r dash of x. So as you can see, it's quite simple. It has three terms. First term has the derivative of the first function, the remaining two terms as it is. Second term has the derivative of the second function, and the third term has the derivative of the third function. Okay, let us see an example. Let us consider f of x equals x cube sin x multiplied with let us say e power x. Okay, As you can see, there are three functions. The first function is x cube, a cubic function. Second function is sin x, a trigonometric function. And the third function is e power x, which is an exponential function. Okay, let us use the product rule for three functions, which is f dash of x equals first term. So this the derivative will have three terms. The first term will have the derivative. First, I'll differentiate x cube, which is 3x squared. I'll keep the second and third term as it is, that is sin x into e power x, plus the second term. I'm going to differentiate the second function now. So I'll keep the first function as it is, into cos x into e power x, plus the third term is, so I'll keep the first two functions as it is, and I'm differentiate the third term, but we all know that derivative of e power x is e power x. That's all. So this is the derivative of the given function. Okay, so let us see one more example. Let us see okay, f of x equals x cube plus 1 multiplied with tan x. Okay, so f dash of x equals, I'll differentiate the first term, which is x cube plus 1, I mean the first function, that is, sorry, so it is nothing but 3x squared plus 0 multiplied with tan x, plus I'll keep the first function now and differentiate the second function. The first function is x cubed plus 1 multiplied with derivative of tan x is 1 by cos squared x. Cos squared x. Okay, so the final answer is 3x squared tan x plus x cube plus 1 divided by cos squared x. That's all. So I hope the product rule is clear for you. Thanks a lot. In my next video, I'm going to explain how to use the quotient rule to find the derivatives of certain functions which are in quotient. Thank you, students.